Okay, so we have learned what a limit is, and now we're going to look at how to find them algebraically. So that means without using a graph. Here's the basic rundown of a limit. So these notes, this is kind of already written out for you, but basically, hold on. Okay. Ooh, no. Wait. All right. So essentially, limits are almost always the same as a value at a point, okay? So more often than not, a limit and a value are the same things. Because of that, a lot of times we can use substitution. We just substitute in our x value, and that will give us the value of that function, which also happens to be the limit. So that usually works out really well. Because that happens so often, we always try that first. Always, every time. The problem is sometimes it doesn't work, but we always try it. So here's what happens. You're going to substitute in this number. You're going to substitute in your x, and this is what can happen. So let me give you an example before we go through this. Like, let's say we have f of x equals, 2x squared minus 4 over x. Okay, so if I want to know what the limit of f of x is as x is approaching, let's say 2. Okay? Actually, let's say 1. Okay, let's say 1. If I want to know that, you're going to take this 1 and you're going to substitute it in here. All right? And then, based on whatever that gives you, you come over to this chart. Now, if you get this, a number, that's not hashtag, that means a number. If you get a number, then the limit is that number. All right? If you get 0 over a number, so let's say you get 0 over 5. The limit is 0. If when you substitute in, you get a number on the top and 0 on the bottom, then the limit does not exist. Sometimes you get a 0 on the top and a 0 on the bottom. And if that happens, this is our most special case. If this happens, it's indeterminate. Indeterminate means they can't tell you the answer right now. It means substitution is not enough to find the limit. Therefore, you must do more work. There are 3 ways we can do more work. You can either factor, you can rationalize, or you can find a common denominator. Today, we're going to look at factoring. So let's come back to our example for a second. If I wanted to find the limit of f of x as x is approaching 1, I would plug this 1 in up here. And I would say 1 squared is 1 times 2 is 2. 2 minus 4 is negative 2. So I've got a negative 2 over 1. So I get negative 2. So this is the limit because it's a number, right? This is what happened. I got a number, that's the limit. What if I wanted to know here the limit with the same f of x, but as x was approaching 0? I would substitute the 0 in up here. And I would get 0 times 2 is 0, or 0 squared is 0 times 2 is 0, minus 4 is negative 4. And on the bottom, I would substitute my 0 in there too, and I would get over 0. I'd come over to my chart here, and now I have a number, over 0, over 0. A number over 0 means the limit does not exist. So you have to kind of translate whatever you get from the substitution into what that means for the limit. All right, now let's look what happens when we get a 0 over 0. So let's look at a problem like this. Okay, so we're going to say the limit of f of x which is going to be x squared minus 16 over x minus 4. So I'm just writing my f of x right in the problem. So the limit of x squared minus 16 over x minus 4 as x approaches 4. Okay, so step 1 is always to substitute. We always substitute in the x. So I'm going to do that, and I'm going to say 4 squared minus 16 over 4 minus 4. All right, so on the top, I've got 4 squared is 16 minus 16 is 0. And on the bottom, 4 minus 4 is 0. Okay, so this is indeterminate. This is not 0. It's not. That's not what it means. This is indeterminate. Remember on our chart up here, we have the 0 over 0, indeterminate. Okay, so that means we have to do more work. We need to do more work. The work we are going to do here is I'm going to look at this and I'm going to decide if I want to factor, rationalize, or find a common denominator. So I'm seeing this is a difference of squares. So factor seems like a good idea to me. So I'm going to factor this. And I'm going to look at the top and I'm going to say, well, x squared minus 16 is the same as x plus 4 times x minus 4. And on the bottom, I have an x minus 4. And oh, look at that. I can cancel. So as soon as you simplify, we're in business. So I've now simplified this down to x plus 4. After you have canceled something out, you substitute in again. All right, substitute in again. So I'm going to now say, I'm going to replace my 4 with that 4, remember, because I had a 4 that I was approaching, plus 4. Oops, I should make that black. And now I get 8. And that's my limit. All right? So I was able to change my function to give me an actual value, an actual number that can also be the limit. Make sense? All right, so let me walk you through those steps again. I substituted in my x. I got an indeterminate. That means I do more work. I'm going to factor. I split it up. I tried to figure out what I could factor. I simplified and canceled something out. That left me with x plus 4. I substituted again. Got a number, and I'm out. Done. Should we try another one? Let's try another one. Okay, let's do, oops. All right, let's try this. Let's say we want to know the limit of x minus 3 over 4x squared minus 12x as x approaches 3. Okay, so step 1, substitute. So I'm going to substitute in, and I'm going to say 3 minus 3 over 4 times 3 squared minus 12 times 3. And I'm going to get on the top a 0, and on the bottom, let's see, 3 squared is 9 times 4 is 36, minus 36, 0 over 0. This is indeterminate. So that means I need to do more work. And I am going to factor. I'm going to try and factor again because I don't know, I feel like I've got a 4 and a 12 and a 3. Those all, I don't know, they kind of go together. All right, so on the top, I can't do anything on the top. I've got this x minus 3. But on the bottom, there's an x, and these can both divide by 4. So I'm going to factor out this 4 and an x, and that leaves me x minus 3. And then I'm like, oh, snap, gone. But I'm going to be careful because there's still a 1 on top, right? So I have 1 over 4x. So here was step 3 also. I simplified. Okay, and now step 4, I'm going to substitute again. Now that I've actually canceled something out, I'm going to substitute again. And I'm substituting in a 3. So I'm going to say 1 over 4 times 3. And sure enough, the limit is a 12th. All right? That's it. That's all there is to it. So you substitute, you do more work. You substitute again. Game over. Eventually you're going to get a limit. Okay, I hope that made sense.